Do you really know how the intersection of a family of sets is defined? The intersection of two sets, A and B, is easily defined as the set of all x, for example, in A, such that x is also in B. But what about the intersection of a family of sets? One would be tempted to define it in the following way. Let F be a family of sets, then the intersection of the sets of F, which we denote in this way, is by definition the set of all x such that for all A in F, x is in A. But this definition is wrong. It is not possible to give this definition when F is the empty set. In this case, this definition would imply that the defined intersection is the set of all sets, because the property that defines the elements of the intersection is, for all A in F implies x in A. But since F is the empty set, the statement A in F is false for every set A. In a basic logic course, you can learn that a false statement implies everything. It implies every other statement. So the property A in F implies x in A is true for every x and for every A. Thus, the property for all A in F implies x in A is true for every x. Thus, every x is in this intersection. So this is really problematic because it can be proved that the set of all sets does not exist if you, for example, admit the Zirmelo-Fraenkel axioms. So how could we fix this definition? You can define it by cases. For example, it could be possible that you want the intersection to be the empty set in the case that F is the empty set. Therefore, in this case, you can give the following definition. The intersection of the sets of F is equal to the empty set if F is equal to the empty set. And it is what we wrote above in the case that F is not the empty set. So this was everything for this video, and ciao to everyone.